afternoon or good evening, gentlemen. Today is going to be the first video on a little bit of revision on the Leaving Cert higher level. So what we're going to do today is look at the equation of a line, and what you should have is your log tables open on page 18 and page 19. So all of page 18 and the first two formulas on page 19, and you will be making reference to your log tables for the duration of this video. Okay, so we're going to start, and I've broken the equation coordinate geometry into three sections. First of all, we're going to look at the revision of the formulas from the junior cert. Then we're going to look at the equation of a line, the only formula in your log tables where there's two formulas, not just one. And then we're going to finish off looking at the four new formulas that you would have seen on the Leaving Cert that were not on the junior cert course. So first things first, you need to be able to know how to find the midpoint, the slope, and the distance formula. Okay, the midpoint is quite closely linked to the Leaving Cert divisor of a line segment, and the distance is closely linked to the perpendicular distance from a point to a line. So we'll talk about those relationships later on. The last thing that you would have seen in the junior cert that you do need to know and remember is how to verify a point is on a line. So verify if a point is on the line, and that is you sub in your x1 and your y1 values into the equation of a line. Let the left hand side equal the right hand side. Okay, so that's the first thing you would have had to look at. The second thing, the big thing that you would have seen in the junior cert but is asked in quite good detail in the Leaving Cert, is the equation of a line. First things first, you will notice it's the only formula where there's two formulas. You have the equation of a line, y minus y1 equals x minus m bracket x minus x1, or we have y equals mx plus c. So when do we use each of them? We're just going to talk about that just for a moment. If we know the 2 points are a point and a slope, point plus the slope, okay, and we need to find the equation of the line. Okay, we would use the first formula, y minus y1 equals m bracket x minus x1. We sub in for m, we sub in for x1, y1. If we are given an equation of a line, if for example 2x plus 3y equals 6, what we need to do is to make y the subject. Okay, so we need to make, when we're given the equation of a line, make y the subject, and m will equal our slope, and c is your y-intercept. Okay, the y-intercept is where it crosses the y-axis. Okay, we're going to look at the y-intercept and the x-intercept now in a moment. Okay, so that's where the two equations are used. So when you are using with the equation of a line, the two things you need to know is x-intercept and y-intercepts. Okay, so actually first of all, before we look at the x and y-intercepts, we need to know parallel and perpendicular. Okay, parallel lines, two slopes are the same. Perpendicular lines, if you had a slope a over b, it now becomes minus b over a. So you inverse the fraction and you change the positive to a plus. After we've looked at parallel perpendicular lines, with the equation of a line, sometimes you will be given limited information and you might have to leave your answer in terms of m. So be very careful reading the question whether they want a specific answer or they want the answers in terms of m or something else. So which are crossing the x-axis and crossing the y-axis, where a point crosses the y-axis, the y-intercept. Okay, y-intercept. Your x value will equal 0. So your coordinate will be 0, c, or so on. And where it crosses the x x-axis. Your y value equals 0. Okay, so pretty much that's what we're going to look at with the equation of a line. So now we're going to move on from looking at what we've talked about with the equation of a line and look at some of your leaving cert formulas. So the first one, with your log tables, we should all see the first one we're going to look at is the point dividing PQ in the ratio A is to B. Okay, so what we really need to worry about, or we need to notice, is that on our, let's see, that's 3:1, x1, the point nearest x1, so you can zoom in. No. Okay, the point nearest x1, y1 will be A. The ratio nearest x2, y2 is B. So just be careful of that. Next bit we're going to look at is the area of a triangle. You will see on your log tables that a triangle has 3 points, and your log tables, the formula has only an x1, y2 minus x2, y1. Also, we have the absolute value because it's area, it's going to be positive. Our third point is going to be 0, 0. If we have 3 points and none of them are 0, 0, we need to use transformations. We need to move one of those 3 points to make it 0, 0. After that, we've looked at the perpendicular distance. Here we go. The perpendicular distance, there we go, in English, x1, y1 to the point ax plus by plus c equals 0. We sub in our values. Just to be careful that we might have to use our information, our knowledge of parallel and perpendicular lines. We might have to move a line to get the point. And then the last thing I want us to look at was the equation of a line, the angle between 2 lines. Okay, so as you can see with your log tables, tan theta equals plus or minus m1 minus m2 all over 1 plus m1 m1 multiplied by m2. What that is we have an acute angle, which will be plus, and then we'll have an obtuse angle, which will be a minus. So that's where we have our, if one angle was theta, our second angle would be 180 minus theta. Okay, so there are just a few of the main points that you need to look at for coordinate geometry of the line. The next video I'll be making will be on the circle, and everything we have looked at today can be asked both in a line question and a circle question, and you will need to build on this information. So if I was asking you for perpendicular distance from a point to a line, that could be a centre of a circle and a tangent, and we'll look at more examples in the next video. Okay, that's the last thing I'm going to say, and if you have any more questions, feel free to post on Edmodo or on Teams. Good man.